webinar titled Artificial Intelligence Essentials for Your Business. Before I hand things over to our featured presenter, Jeff Felice, today, I'd like to tell you a bit about him. As president of CertNexus, Jeff is responsible for advancing the company's mission of closing the emerging technology skills gap. With 25 years of experience within the training and certification industry, serving in general management and practice leadership roles, he combines his passion for professional performance with technology to bring change within global organizations while improving the opportunities for individuals in emerging tech. He's also a very dynamic speaker, and we're honored to have him here today. Jeff, you now have the floor.
Great, thank you so much, Mike. I appreciate everyone taking the time to spend an hour with us today and talk about artificial intelligence. And as Mike said, whether it's morning, afternoon, or evening, we do appreciate your time. So we are going to talk again about artificial intelligence and just give us a brief overview to what artificial intelligence is. As Mike shared, my name is Jeff Felice, and I serve as the president of CertNexus. If you're not familiar with CertNexus, we're a certification body under neutral emerging technologies. So some of you are coming to learn about artificial intelligence, but don't recognize that you're already engaging or interacting with artificial intelligence each and every day. So most of us have smartphones. Smartphones contain artificial intelligence. Some of us may have home assistants. So whether that's Alexa or your Google Assistant, they also contain artificial intelligence. Some of us may be wearing a Fitbit or an Apple Watch or some other type of wearable device. Again, many of them not only have what are considered Internet of Things connected to the internet, but also contain AI. When we go online shopping, so whether you're on Amazon or your favorite retailer, again, using artificial intelligence. It's the same when we perform a search, whether that's on Bing or Google or DuckDuckGo. Again, they're all backed by artificial intelligence. And then as we enter the workplace, whether that's a physical environment where we're manufacturing goods, where robotics are used, maybe it's an agricultural setting. Again, we're using more advanced AI in our tractors and in how we actually manage our crops and livestock. And it can be anywhere in any workplace, again, whether it's data centers, heating and cooling, etc. But we're using more and more connected devices, and many of those are inclusive of artificial intelligence. So as we start to explore artificial intelligence, we want to get an understanding of where you are today with AI and your use of it, whether in the workplace or at home. So Olivia is going to post a poll question here, and the poll's open. And Olivia, I cannot see the poll right now.
Yes, the poll has been launched, and we'll give them about another 30 seconds to answer.
Okay, great.
Are you able to see the results, Jeff?
I am not able to see that.
Okay, I'll read them off for you.
Okay, great.
So
Thank you.
we have, I use technology that leverages AI at work at 44%. I am responsible for developing AI solutions at 39%. And then my job does not require me to interact with AI at all at 6%. And I use technology at home that uses AI, so 44% as well.
Great, great. Thanks so much, Olivia. And thanks everyone for answering those questions. And that is common where we see many of us are using it at home, as we described. And many of us are involved in AI in some of the workplace, whether we're actually developing or deploying AI solutions or we're consumers of those solutions. So what are we going to learn today? We're going to start with a brief history of artificial intelligence, and then define the types of AI, the various approaches within those types, and we'll just start to touch on how AI is transforming industry. And then we'll have a period of roughly 15 minutes at the end for Q&A. So I'm going to ask everyone just to sit back, plug in, and we'll start to transfer some knowledge to you. So let's start with a history of artificial intelligence. So modern AI, many agree that it originated with Alan Turing in the UK with the Turing test in 1950. Some will debate that AI was formed prior to then, but most will agree 1950 was its origins. In 1956, the term AI was actually birthed at Dartmouth College. And then we had some initial implementations or uses of AI. We had Unimate, which was our first industrial robot in a General Electric factory, which was actually performing some welds on machinery. Then we had ELIZA, which is our first approach at natural language processing, and we'll learn a little bit more about what that is. And then we had Shaky, which was our first general purpose robot. And Shaky might have been the initial end of AI. In fact, that AI, much unlike other technologies which have a continuous progression, we actually had a period where we called winters, where there was little time and resources in AI. There was actually a paper written in the early 1970s, 1973, published in the UK that said, hey, listen, we're never going to realize the full potential of AI. So let's focus our efforts elsewhere and with other technologies. And so for really a period of 20 years, we had little investment in AI. There was a brief period where we started to invest in it again in the mid 80s, but again was soon supplanted by personal computers. So from the early 1970s to the early 1990s, we had very little investment in AI. And then IBM released Deep Blue. And many may recognize Deep Blue, especially if you've been around technology for a while. And it's most famous for beating Grandmaster chess champion Garry Kasparov in a series of chess games. Kicked off at least the broader understanding of what AI was capable of doing. Then we had implementations of AI, some most notable, which was the Grand Challenge. This is essentially a course that was established in the western parts of the US, where autonomous vehicles were attempting to circumvent a course. The first year, none were able to do it. In the second year, in 2005, were able to do it. But again, these were all more, I would say, research-based type of implementations of AI. It really didn't reach the workplace or our lives. That really started to happen in 2011. For most of us, with the advent of smartphones. Even though the first versions of Siri were actually not AI, they were just a number of advanced algorithms, Siri and other smartphones soon adopted AI. And then we continue to see continued progression. IBM supplanted Deep Blue with IBM Watson, which is their current AI today. And then Google released DeepMind in 2016, which was notable is the first general purpose AI as well. And also notably for beating the AlphaGo champion at the time in the game of Go, which is most see it as the most complex board game. So over this period of time, over the past 70 years, again, we saw a period where there was little investment. In the last 20 plus years, significant investment. And really in the last 5 years is where we've seen the explosive growth of AI. It's still considered an emerging technology because it has so much potential still. But over the past 5 years, we've seen significant investment from governments. It's almost now the new space race, which is AI, right? Governments literally investing billions, many billions of dollars into AI. Some of these dollars are going into research institutions. So you'll see the leading universities across the world actually advancing AI, and then also an industry in itself. Initially, much of that was concentrated in big tech, but now it's starting to expand out into all industries and seeing significant investment from industry as well. So that's a little bit of background or the history of AI, but let's describe what AI is. First, what we have to understand is computers do not have intelligence, right? We've prescribed a term for sentient or thinking beings to computers. But what we have done is we've prescribed this term for computer systems that are able to perform tasks that we consider typically require some level of intelligence. This is things like visual perception, speech recognition, actually the ability to produce speech, decision making, and other advanced, what we'll call intelligent tasks. So when you think about artificial intelligence, it really is this technical concept of what we've done is given the ability for machines to have some capacity to think or perform tasks that require thought. Then we have to look at the progression of AI. So even though we look at AI and we look at the vast capabilities of it, the fact is, again, we're still in a very nascent phase of AI. And in fact, what we have is what we call artificial neural intelligence, or ANI. And artificial neural intelligence is that these AIs, the AI that we're developing, all of them, even the most advanced AI that we've developed in the world, are really good at doing one thing. The most advanced AI in the world, and we'll talk about that more later, GPT-3, is really good at natural language processing, but it's not good at computer vision. It's not good at other types of AI. So again, what we've done is we've created these AI that can do one thing really, really well. The next progression of AI, it was general intelligence. And this is where computers would have intelligence equivalent to humans. Some say we'll reach this in the next 5 to 10 years, especially if there's continued progress in quantum computing and other computational capabilities. Some say we may never reach it. And most agree, as in some hope we never do reach, is super intelligence. And this is really the stuff of film and television today, where essentially there's a computer that has intelligence that is at least exceeds, if not far exceeds, humans, and may even run the world. So obviously you can understand why there's some hesitancy around that. But again, today what we've really achieved is this artificial and narrow intelligence, or ANI, with some level of progression towards general intelligence. So now that we've defined artificial intelligence, let's talk about the two primary types of artificial intelligence, being machine learning and deep learning. Machine learning is what's most often today, and we'll learn for several reasons why. But this is essentially giving the ability for computers to essentially process data and using algorithms and statistical models to analyze that data and actually make predictions from that data. So machine learning is used widely. We'll talk more about that, how it's used in industry. But essentially what we're doing is we're taking data, we're essentially allowing the algorithm to essentially learn from that data and then process more data through it to make predictions. Deep learning is a subset of machine learning. It's actually comprised of what we call neural networks, and typically 3 or more layers where this information is processed. And it's a more complex version of artificial intelligence. So machine learning is widely used. Deep learning is widely available, but it has been more concentrated within research institutions and big tech, although it'll be more available as we create lighter weight deep learning models. So how does this all work together? How do they relate? So artificial intelligence is that, again, umbrella concept we often talk about as a technology. Machine learning, again, being the most often used type of artificial intelligence, and deep learning being a subset of machine learning, and again, we'll see for our most complex problems. So how does this work? Well, if you think, let's start by thinking about how traditional programming works. So if you think about a traditional program, and I'm oversimplifying here, but it's a series of nested if-then statements, right? So if I select a cell in Microsoft Excel, it bolds. If I type 1, 2, 3, 1, 2, 3 displays. And this is where machine learning diverges from traditional programs. So we're still using an algorithm, but what we're doing is we're selecting an algorithm, and then what we're doing is we're taking data, what we call a set of training data, and we input that into the algorithm. The algorithm is going to make predictions. It's then going to evaluate those predictions. But then this is again where it changes. It's actually going to learn from the predictions it makes, and it will improve the algorithm. So as opposed to have an algorithm that is static and is only told what only does what it's told, this algorithm is going to learn. So as we process more and more data through it, it continues to learn. So for example, I take a set of data through it, and it will learn. For example, let's say it's going to audit expense reports, and it understands that beer is an alcoholic drink. Well, what about root beer? The first time it made it as being an alcoholic drink because it has the word beer in it. But then it will learn over time that it's root beer. It won't make that mistake again. Thereafter, it will make sure that it always is labeled as a soft drink. Deep learning, again, a more advanced type of AI, is processed in layers. And so a typical deep learning artificial neural network, we'll learn more about that term in a few minutes, will have these multiple layers made up of nodes. And so what we do is we will input some type of data into it. In this scenario we're using here, it's an image. And that first layer in the neural network is going to say, hey, this image is made up of shapes, whether it's a crescent moon, a triangle, a rhombus, or an ellipsis. And then it's going to say, hey, you know what? These shapes actually look like parts of a face, whether that's a mouth, eyes, nose, and ears. Then it's going to start to assemble that information together and say, hey, this is actually a face. And then it's going to predict whether that face is a human face or a rabbit face. In this case, it correctly predicts that it's a human face. So you can see how this deep learning artificial neural network is essentially processing information. So when do we use machine learning versus deep learning? Well, typically machine learning is used when we have less data. Deep learning requires, today anyway, long data. With machine learning, as we'll learn in the next couple of slides, we know more about our data. We can actually classify that data. With deep learning, we know a little bit less about our data, or the data is so vast that we want the algorithm itself to start to classify that information. And in fact, in machine learning with the algorithm, we typically will guide the prediction. We'll see label an outcome or work hard to help the algorithm to do that. With deep learning, the AI is making predictions. So the deep learning algorithm is going to make those predictions with very little, if any, input from humans. And machine learning, although it can solve complex problems, it's less effective at solving the most complex problems that deep learning is used for. So deep learning is going to be used for natural language processing, computer vision, and our more complex uses of AI. So we have another poll here. So Olivia is going to turn that poll up. And Olivia, if you could read the question.
Sorry, Jeff, what were you saying?
If you could just read the question, because I'm unable to see it.
Oh, yes. What level of AI have we achieved?
Great. Thanks, Olivia. And this is the only question where we're going to ask for you to recite back some knowledge that we shared with you.
We'll give everyone about another 20 seconds. I see the votes are still coming in.
Okay, great.
Okay, and for our top result, we have artificial general intelligence at 53%, followed by artificial narrow intelligence at 40%.
Right, and the correct answer, the most correct answer, I should say, is artificial narrow intelligence. So we have achieved ANI, and we're working towards artificial and general intelligence. So either of those answers would be correct. ANI is probably more correct because it's what we achieved so far, but again, working towards artificial general intelligence. Great job, everyone. Thanks for participating. So now that we've defined AI as this technical concepts and the types of AI, machine learning and deep learning, we're going to talk about the approaches of each of our types of being machine learning and deep learning. So we're going to start with machine learning, and there's three primary types of or approaches to machine learning, which are supervised learning, unsupervised learning, and reinforcement learning. So supervised learning. This is a machine learning approach where we know more information about not only the data, but with the outcome we expect to see. So we're going to use an example of medical records here. And so within this example, we have three primary components. An example, which is an individual instance of a data. And so in this case, it's a patient, and we are using patient IDs here. Then we have features. These are measurable properties. So in this case, it's an individual, height, and their blood pressure. And then we're going to label the outcome. In this case, it's binary of do they have heart disease, yes or no. So what we've done in the supervised learning is we're taking all these medical records. Each, again, patient is an example. Each of them has a measure being a feature. And we know with this initial set of data whether people have heart disease or not. So what we do is we take this training data and we run it through them. We know that some people have good heart health and some have poor heart health, and they have associated features, in this case, measurable properties of height, weight, and blood pressure associated with their heart health. And what we do is we run that through the algorithm, and the algorithm starts to learn and classify. Hey, people that are probably not at an optimal weight and or have high blood pressure typically have heart disease. So then what we do is when we take new data and we run this through the algorithm can now predict. So we have not determined what's with this data, whether someone has good or poor heart health. All we know is they have a certain height, they have a certain weight, and they have a certain blood pressure. And the algorithm learns that, hey, this person, again, may have a less optimal weight or have higher blood pressure, and therefore does not have optimal heart health. So this is a very simplistic version, but you think about this when we start to take data, large volumes of data, and we've done this, and we'll talk more about this when we talk about the healthcare industry, where we've taken large volumes of data and now can start to make predictions. Obviously, you still want to get a specific diagnosis from your doctor, but algorithms can start to help us make larger scale predictions. Unsupervised is very similar, except for we're not labeling the outcome. So in this case, what we're going to do is, again, we're going to have certain features. We're going to have individuals that are examples, right? They're patients. And some individuals will have good, healthy eating habits. Some will have less optimal eating habits. Some will be sedentary, and some will be active. But what we haven't said is whether they have heart disease or not. What we're doing is we're going to put the data into the algorithm, and we're going to let the algorithm select how to group these individuals and whether it's likely that they would have potentially heart disease or potentially other health challenges as well. So in this case, it's less prescriptive with unsupervised learning, and we're allowing the algorithm to essentially provide, have more influence over the predictive outcomes. So that's between supervised and unsupervised learning. Our third primary type of or approach to machine learning is reinforcement learning, and this is often used in gaming and robotics. And how this works is we can see we're playing a game of chess here, and we select a chess piece, which in this case we're taking a pawn. We're then moving that pawn forward two spaces. The environment has changed, and a reward is given if that pawn has not weakened. In this case, the black chess pieces, it hasn't weakened its position on the board or been taken or captured. And then what it'll do is it'll give a reward, so the next time it will do this. And this is how Deep Blue was actually able to beat Garry Kasparov in a game of chess, because it actually could play through all of Garry Kasparov's games of chess, plus all the other great champions of chess. And it played millions and millions of games of chess. And so when it went to play someone like Garry Kasparov, who grandmaster champion, it knew all the potential moves on the board, not only for the current move, but moves far out from the existing move as well. So that's how reinforcement learning works. It also works the same in robotics. If a robot extends its hand, a human extends its hand and shakes it, it's going to next time engages with a human do that. It engages a dog, it extends its hand, the dog doesn't shake its hand, it won't do that the next time it engages with a dog. So essentially that is the basis of reinforcement learning. Deep learning is different. As we described earlier, we use what we call neural networks, and these are called artificial neural networks, or ANNs. There's two primary types of neural networks, feed forward and recurrent. We don't have time to get into those two, but we will take a look at what an artificial neural network, what it consists of. So you remember, if we went back to our example before where we had that image, which was at an input layer, and we were processing it through multiple layers to say, hey, it was a shape. That shape was actually a component of a face. These components make up a face, and then we were determining whether, predicting whether that was a human face or a rabbit face, and we correctly predicted a human face. Well, that is an artificial neural network. It's essentially taking information and then we have multiple layers where we're processing, at least 3 layers where we're processing that information, and the output layer. So we've actually, again, used human terminology or biological terminology for how these neural networks work. So if you think about the human brain consists of neurons. Those neurons are connected by synapses. There are electrical currents that go over those synapses to those neurons, which allow me to do the things I'm doing today, which is I'm able to read to you while I'm also speaking, moving my hand as well. So I'll being able to do all those things at once because of the electrical currents that are running through my brain. Well, it's similar for a computer. In this case, instead of neurons, we have nodes. Those nodes are assembled into layers, and those layers and those nodes are connected. And what we're doing is we're taking information and we're passing it from one layer and nodes within that layer to the next layer. And then the information is getting processed at that layer. Again, we may have multiple of those intermediate layers processing different levels of information. And then we have an output layer, which is, again, that predictive outcome. So an artificial neural network, again, is because of these layers, we are able to process more complex sets of data and allow the algorithm itself to make greater predictive outcomes as well. So we've looked at artificial intelligence as a technical concept. We looked at the two primary approaches being the two primary types being machine learning and deep learning, and now the approaches to each one of those. So for machine learning, we looked at reinforcement learning, supervised learning, and unsupervised learning. And we started to dig into deep learning, and it's being comprised of artificial neural networks, and those neural networks are processing information across layers. So now that we understand the basics of AI, we're going to talk about how AI is transforming the industry. So I want to start by saying we're going to focus on 3 areas, being finance, healthcare, and retail. But before doing so, I want to note that AI is used across all industry. There's not an industry today that is impacted by AI. Some of them are generating or creating the AI themselves. If not, many of them are consumers of AI that are using it to advance their business. The other thing, as I noted earlier, is that it's not only AI is not only used within an industry, but it's also being used by government. So, I sit in the U.S. The U.S. government is investing, again, billions of dollars in AI to advance AI for, again, not only government use, but for industry. And they're sometimes doing that in partnership with industry and also with research institutes, from some of the largest and most notable academic institutions. So again, although we're going to focus on three specific industries here, it's used across all industry, and also what I would say companies of all sizes. I work within a small and mid-sized company. We use AI. So we use AI across our organization. AI within our e-commerce platform. We use AI within our sales customer relationship management platform. We use it in our marketing automation platform. We use it in our enterprise resource planning platform. And we use it in other parts of our business as well. And it's probably not atypical for most businesses. It's, again, not ours is used across industry, but an organization as well. So again, technology that is pervasively used, but also an emerging technology in the fact that it has so much more potential that it can deliver to organizations. We're going to start first talk about its use in finance. Finance is probably one industry where AI is being used most extensively. Others would be considered would be healthcare and manufacturing, but again, is being used across all industry. So in finance, we're using it for fraud detection. You think about the number of transactions that occur in a payment card company like, you know, a Visa or American Express or whatever the payment card may be. The fact is that they many times are providing insurance to the individual that, hey, if there's any fraudulent activity that occurs, that it won't impact the individual. So obviously, they have a responsibility not only to their customers, but to their business to be able to thwart any potential fraudulent activity. So they're using AI to help do that. Now, the most simplistic form is looking for unlikely transactions, right? So prior to COVID, I used to travel extensively, but I've never been to Brazil. When I travel for business, I typically don't stay at high-end resorts, and I typically rent a flashy car. So if you saw on my American Express 6 tickets to Brazil, say for a high-end resort, and someone renting a Lamborghini, those would be immediate flags, right? That's more than obvious. But think about the more nuanced transactions. What about, yeah, I do have a phone. I bought a phone. But what if I had just bought a 3 months ago and I bought another phone? And what if that phone purchase was not outside of Atlanta where I live today? So now there's, again, what's happening, they're using AI to help detect these potentially fraudulent activities and flag them or potentially halt the transaction itself. We're also using it in advisory services. So you think about if you have a financial advisor or their institutional advisors, they're using more and more AI. There's no crystal ball yet, and I don't know if there ever will be, because right, our economic progress is based on so many factors, and those factors include humans, and humans are are not always predictable. So our advisory services will never be 100%, but they're improving upon them. So financial advisors can actually provide better recommendations to the investors that they support. Also to assess risk. This can be risk from potential investments, but also in lending practice. There is some controversy around this, the use of AI in lending practices, because we didn't talk about this earlier, but there is some concern with AI and the ethical use of AI, and making that the data that you're using to train an AI is not biased and conforms to the ethical norm of a nation or at least a community of people. And AI doesn't understand that. It only understands the data that you've provided to it. So risk assessment could be, hey, I want to make sure I'm lending money to the people that are most likely to pay it back. So the financial industry is using AI to do that. The concern is that it may be biased against a certain segment of people. Some of the initial AI was essentially biased against people in a certain location because there was a higher default rate in a certain postal or zip code. but now we're working on improving the AI to remove some of those biases and again, conform to better ethical norms. AI is also used in healthcare extensively. So in diagnostics, we're using imaging. Again, a doctor will always be the final decision, but we're starting to be able, and AI may be able to pick up a potential disease state at a sooner phase. We're also using it in prevention. There was actually a university out of Lithuania that actually had just completed an initial study using AI, where they were able to better diagnose the onset of Alzheimer's disease. There's obviously a lot more research that needs to be done, but working towards that. IBM just actually paired with the Michael J. Fox Foundation and actually has started to map the progression of Parkinson's disease, which before had eluded, I would say, healthcare practitioners and how to do so. But through the use of AI, IBM's AI, they're able to now better understand the expected progression based on the disease state and the future. We're also starting to use AI to help diagnose treatment. So again, early stages, but getting better at saying, understanding the human body. So for example, AI was able to just better be able to construct proteins. So there's, I don't know how many proteins, but there's many of them. And AI was able to do that, which again, before individuals were unable to do so, and they were able to do it in record time. It was amazing how quick it was able to work through that. So again, AI will continue to have healthcare practitioners, but AI is going to help us do things in scale that we're able to do and better understand how the human body works, how it may be prone to certain disease, and then how to prevent that and/or in the treatment of those diseases as well. And then retail, right? All of us buy something, whether that's groceries or clothing or other recreational items. And when we're engaging in retail, we're almost always, especially when it's online, we're always typically engaging with some level of AI, right? That AI will be used for recommendation engines, right? I'm an avid cyclist, so if I purchase cycling shoes, it's going to then recommend that I purchase stocks, right? And I'll start to display ads and across my social media and other recommendations to do. I also, when retailers are using it to actually present information to me and potential discounts or other incentives to purchase as well. We're starting to see it in physical stores. So we're starting to see where we're starting to track the footfall within a store. Where are people going to in a store? Where are they looking on the shelves? What are they actually taking from the shelves or putting back on the shelves? In fact, Amazon is going to be opening up 2 Whole Foods. For those who don't know, they own a grocery chain, Whole Foods, and be opening up 2 stores in the next year that will be entirely cash register free. So individuals will literally go into the store, take items off the shelf, put it into their cart, and actually leave the store without actually providing any type of payment. And then they'll be automatically charged based on essentially what they took off the shelf and put into their carts. So again, that's all AI backed. We're starting to use it for security as well. So not only having just CCTV, utilizing AI to be able to look at actions within the store and maybe something that, again, maybe an action that would be responsible for theft, right? So if I took something off the shelf, and that's one thing. If I actually put it under my coat, that would be yet another, right? And so being able to identify that and alert the appropriate personnel. So again, we're using it for so many different ways. On the last, and this is not just retail, but is in support, right? More and more of us are engaging with chatbots, right? So we'll actually be prompted with a series of questions, and chatbot can answer that question altogether, or actually route us to the appropriate customer service rep who has expertise in that area. And AI is having an impact on the workplace. Microsoft, as you can see here, they looked at the digital job capacity and growth from 2020 to 2025. And they look at the creation of roughly 150 million new jobs. And the AI and data economy is responsible for most of that. So you can see there's going to be millions more of cybersecurity positions, tens of millions of folks that are involved in data, whether those are data analysts or data scientists, machine learning engineers, deep learning engineers, people that are involved in cloud, and again, data associated with that, right? The cloud has allowed us this expansive capability, both of storage and power, to do more with data, to collect more data, whether that's through social media or IoT platforms, and then be able to process that as well as whether data scientists or analysts, or through the use of machine and deep learning as well. And then again, more and more software development as well. So you can see our workplace will continue to evolve and change as AI continues to be adopted on a wider scale. Again, reducing some of the most rote tasks that we perform that are repeatable, and allowing us to focus on higher cognitive and more interpersonal or intrapersonal activities that require a higher level cognitive and emotional thought. With that, we're going to go to our final poll. So Olivia, if you could bring that up for us.
The poll has been launched, and the question is, how much do you think AI will impact your job in the next several years?
Great, thanks, Olivia.
We'll give everyone another 20 seconds to answer. Okay, and for our results, we have it will require me to learn more to do my current job at 69%, followed by it will require me to look for a new job at 13%. It will not have any impact at 6%, and unsure at 13%.
Great, thanks so much, Olivia. And that's what we expect to see as well, that if you look at the World Economic Forum, they're projecting, again, much like Microsoft, many millions of new jobs. So jobs that don't exist today. But in most cases, people are going to continue to do the jobs they do today, but those jobs are going to change, right? For people like myself that have been in the workplace for decades now, I started prior to the advent of smartphones, and just as cell phones were being used, right? And that's changed how we work. It's the same with at the level of connectivity that we have today as well. And so AI is going to have that level of impact on most jobs. Again, not all, but most. And again, we'll see many new jobs, and then we'll see again some towards obsolescence. But that's no different than with the previous technologies, right? We don't have typing pools any longer. Everyone, typically has a computer and types their own emails and other documents. We'll see that with AI. And again, as most of you shared, you're going to need to refresh or gain new skills as we move forward with the implementation of AI and migrate more and more into this AI data economy. So with that, right before Q&A, we'll summarize. So again, what we've learned today is AI is a technical concept. It's often implemented using machine and deep learning. We have different approaches to machine and deep learning. So with machine, we talked about supervised and unsupervised and reinforcement. Deep learning, we talked to the fact is it's artificial neural network, and there's different types of those, which we didn't get to explore as much today. We also then started to touch on the fact that AI is used pervasively throughout industry and also by governments and academia as well. And really that the AI and data economy is changing the skills we're going to need to continue to thrive. Again, this is just a taste of artificial intelligence. Our goal for today is hopefully you can walk away and the next time you engage with AI, whether that's your smartphone, your home assistant, potentially as you're using Netflix and using its recommendation engine, or your online retailer, you can start to understand what is AI and the fact that there are these algorithms that are helping to personalize information, potentially promote information, or otherwise engage with me, hopefully in very positive ways. And with that, we're going to move it to our Q&A.
Yeah, thank you so much, Jeff. And as Jeff mentioned, if anyone has questions, please take a moment to type them into the questions box and we'll get to them shortly. And if you're interested in the material presented in this webinar, or if you have questions regarding available course offerings, please contact your local New Horizons Center for further information. You can log on to newhorizons.com and do a zip code search to find the center nearest you. Our webinar schedule is also up to date on our website, newhorizons.com. Just click on the webinar's link to view the full schedule and register for any upcoming sessions. And a friendly reminder, we will be sending out the recording link to today's webinar later today. So here are a bunch of questions. Jeff, let me start with the first one here. As a project manager, how would I use AI?
Yeah, so one thing I will say is that with emerging technologies, unlike traditional technologies, what it was the concern of the IT team. You think about your network operating system. How many of you care really if you're using Windows Server or Linux Server? Most of you care about access to your file network, right? That's different with emerging technologies. With emerging technologies, we're going to have a greater understanding of how these technologies work and will impact our organization across the organization. So whether you're sitting in marketing, sales, legal, finance, you're going to be impacted by these technologies. It's the same with project managers. Many project managers are now leading emerging tech or digital transformation projects. These digital transformation projects typically are emerging technologies such as artificial intelligence. So you're going to have an understanding of these because they're going to be a little bit different. It's not just about creating an application and then you deploy that application. Essentially, these are going to again change, right? They're not in a static, right? So there's no sense of stasis with algorithms. So as a project manager, you're going to have to understand, hey, what's the data that we collect to appropriately train these algorithms, and then how do we manage algorithms going forward as they continue to grow and learn more as well. And even many project management platforms are starting to incorporate some AI into them to help build better timelines, to better understand what are some of the dependencies and potential challenges within a project as well.
Wonderful. And what's the most sophisticated deep learning model?
Yeah, the most sophisticated deep learning model today is what's called GPT-3, or you'll see GP-3. It was created by OpenAI and since been licensed by Microsoft. And this deep learning algorithm is capable of doing really complex natural language processing. And we didn't talk a lot about natural language processing or NLP, but it's actually able to not only analyze text, it's able to generate text as well. And so it actually was built using 175 billion parameters to actually create this. And if you go out and just Google or go out on YouTube and just do GPT-3 and look to see what it's capable of doing. There's actually some demo sites where you can actually interact with it as well. But it's highly advanced. But again, it's AI and it's really good at doing, right? It's not going to be able to make you lunch or drive you to work tomorrow. But again, it is pretty incredible what it's able to do in regards to language.
Interesting, interesting. And where can I learn more about AI?
Yeah, so obviously, New Horizon has a variety of AI courses and classes that are available. Again, what I think people need to understand is that you're going to have technical courses for machine learning engineers or AI engineers. Also, you think about it, AI, as we've learned today, is highly dependent upon data. So again, you're going to have to look at those individuals that are involved in aggregating and administrating that data, so big data engineers, those who actually start to essentially wrangle the data, sense of it, and model, data scientists that are actually then preparing the data for machine learning engineers. So you have all those technical courses, but then also you have data analysts, right? They're now starting to take that predictive outcomes from the AI or handoffs from data scientists and being able to make sense of it and present it to the business. And then you also have, again, across the business, luckily some of us today are from other parts of the business, and we need to understand AI. Again, it's not a concern of IT any longer. It really is something that the entire organization is going to have some command, at least of the foundational terminology and concepts to be effective as you move forward, and whether it's developing new products, implementing projects, or using it for other aspects of your business.
All right. And on slide 22, when you talked about reinforcement learning, step 4 talks about a reward given. What reward does one give a machine? How does that work?
Yeah. It's not a cookie. So essentially the reward is, it's positive feedback into the algorithm itself. So if they had moved that chess piece 2 squares and the chess piece was captured, it would have noted that, hey, that actual move led to essentially a negative outcome, and the algorithm would have learned to say not to do that in that situation again. So again, understanding all the exact chess pieces that are on the board, their position on the board, and the position that happened, it would know that would not lead to a positive outcome. If it had led to a positive outcome, again, the learning, essentially that positive reinforcement or reward is essentially saying to the algorithm, this move worked and it led to a positive outcome. Actually, it starts to bank all that knowledge, if you will, using kind of general terminology, and will continue to look for those rewards. So if it's in that situation, it will not make that move based on the reinforcement.
And what protections are there to prevent inaccurate AI learning, and are there security issues we need to consider?
Yes and yes. So I'll start with the security. So from a security standpoint, yes. First off, we should note that AI is being used extensively within cybersecurity today. I actually just did a presentation a couple weeks ago on that. And we're using AI extensively and with phishing filters, vulnerability assessments, in actually looking at across software vulnerabilities, et cetera. So AI, we will not have cybersecurity in the future without AI. The reason for that is because the criminals, the cyber criminals or hackers, are using AI to try to gain access to our infrastructure and data. So we do have to have concerns for security, and it's being used in security. Also, data privacy. So we have to understand that an AI that it should not identify me as Jeff in that X address with Y social security or other driver's license number, whatever it may be. It can compile that information and present that information. So we need to understand the various data privacy regulations. And then from a is good, bad. The idea is that AI should be used, but again, AI doesn't understand that. And we actually have produced and available through New Horizons as well. We have an ethical AI or data ethics offering as well, and for professionals and lead. For AI ethicists and machine learning engineers, et cetera, and releasing one for professionals as well. But it's a big concern because we've trained our AI to date on the data that we had, and many people didn't recognize, using that banking example earlier, that hey, these people code essentially had higher default rates. But if I move to that postcode, then all of a sudden I get lumped with the people that had that higher default rate. And that's what the AI would say, it would not give me a home loan. That we've seen the same thing in the use of facial recognition in the criminal justice system. And we're now pulling back because in limited cases, but still was happening, was people were being identified for crimes they never committed and having to answer to that. So now what you're seeing is a couple things, is we're starting to train machine learning engineers, AI engineers about ethics and the understanding of the impact data has on ethics and bias. And you're seeing an emerging discipline grow as well, which is AI or data ethics or tech ethics, depending on multiple terms used for it right now, where these professionals are now being hired by companies like social media companies like Twitter and some of the other largest companies in the world to ensure that the AI that's being produced is ethical and contains less bias against individuals or groups of individuals.
All right. And this question says, my company really isn't using AI yet. How do we get started? It seems a little overwhelming to us.
Yeah, you know, in the course we deliver for professionals, we actually have a slide. Now we say this slide is the key takeaway for all business professionals. And it's really understanding, will AI deliver value to your business? It's like any other technology. If it's not going to deliver value to your business, then it's not the right solution. But for most organizations, it is. So then once you value you want to deliver, let's say it is higher customer satisfaction, then you have to understand what's the information or insights that are going to deliver that value. And then what are the resources available? And resources are individuals that can deploy AI. That's also computation, right? Can you actually develop machine learning and then actually, or deep learning, and do you have the computational power? But then do you also have the data? And that data may be your business data, it may be data you acquired third party, whether purchased or open source, that will help drive the information or insights that will deliver the value. But you really have to start with what's the problem. And what I would say is there's probably not any general business problem today that could not be helped, facilitated through the use of AI. It's just understanding what that problem is. So what I would start with is, going back to your business list, what are the 3 largest, obstacles or opportunities for our business? And to think, hey, are they dependent upon data? And do we have data available, or could we gain access to data? And will that data help us to drive that value that we expect for our business?
Wonderful. Well, thank you so much for joining us, and thank you, Jeff, for speaking today. Really appreciate it. This concludes today's session, everybody. Thank you very much for joining us as well.
Thank you, everyone.